So to simulate drawing an arterial blood sample off of a closed arterial line catheter, I'm going to use this manifold to demonstrate how this is done. And what I've done is I've connected a sample syringe here, which is going to be used to simulate the blood coming from the patient. And what I'm going to do first is inject some of this blood into a non-venting aspirating syringe, which is the common syringe used today when drawing off of an arterial line catheter. And you'll notice right away there's going to be a problem in using this particular sampling technique. So what I've done is I've adjusted the stopcock valves here that allows the sample to move from the blood syringe only to the aspirating syringe first. And so what I'm going to do is go ahead and push this plunger forward, and as I do that, the non-venting aspirating syringe is going to go ahead and fill. And you can see where the problem is immediately. And this has to do with the air bubble that is now trapped inside of the syringe. And the air bubble comes from the dead space of the syringe luer tip and the dead space of the arterial line catheter. The issue with air bubbles as a potential source of pre-analytical error is becoming of greater importance now that smaller sample sizes are becoming more common. Many contemporary ABG analyzers and point-of-care devices only require a few tenths of a cc of blood. And the dramatization shown in this picture, the syringe on top has 3/10 of a cc air bubble in it, which occupies a small amount of the total sample size. The syringe on the bottom has a half cc of blood and the same 3/10 of a cc air bubble. Obviously, the air bubble occupies a much greater proportion of the blood sample, so that the equilibration of blood oxygen and carbon dioxide with the gases in the air bubble will occur much faster and more completely. Therefore, the prevention of air bubbles for small samples is even more important for the prevention of pre-analytical error. This is attached in simulating how a blood sample would be drawn from an arterial line. And what I'm going to do now is push the reservoir syringe forward, and the aspirating syringe has been shut off. The venting syringe is now open. It is filling under arterial pressure. The air inside the syringe is now venting out. And once I've obtained the desired amount of sample volume, the syringe filter swells and automatically shuts off, and as you can see, there is no air bubble trapping. This is a common arterial line catheter closed system that is manufactured by Merit Medical in Utah. Very similar in concept to the Edwards Life Science, which is the market leader for closed suction catheters. So basically how this system works is you've got on one end of the catheter a spike line that goes into an IV bag. So the spike goes into the IV bag. IV fluid then runs down this line, and right here is a plug-in to the monitor that goes to a pressure transducer, which is used for hemodynamic monitoring. And then just down from the pressure transducer is the closed system syringe that is used to pull waste fluid, which is the fluid that's contained in this part of the line, and at the very end of this line is what connects to the actual catheter that goes to the patient. When these arterial lines aren't in use, it's important that the blood does not clot inside the line. So that's the purpose of the waste fluid. The waste fluid is usually saline, sometimes it's saline with a heparin mixed with it, but basically used just to keep this arterial line right here open. So whenever you're drawing from an arterial line catheter, what you need to do is pull off all of this waste fluid first, and the blood follows that waste fluid. So we're going to be sampling arterial blood. So the first thing we need to do is to adjust the stopcock so that I can pull back like this, and what's happening is any waste fluid that's in this part of the line, this part of the catheter, then is pulled into the syringe, followed by the blood sample. Once the blood sample reaches the point of where this port is located, this sampling port, then you would take a syringe, which would involve the use of a blunt cannula, because this is no longer a system that uses a regular stopcock system. This is a closed system. So there are various type of valve mechanisms that are used, but they're all accessed by using a blunt cannula. This particular blunt cannula does not have an outside collar or shroud to it. It's just got a blunt tip to it. And what you would do is take this and place it down onto the port, push it into the port, and either aspirate the sample, which is not the correct technique for sampling off of any arterial line, and I'll speak to that in just a moment when we get to pre-analytical error, or you can vent the syringe, which is the proper way of obtaining the sample. Presetting the plunger, allowing the sample to then automatically fill into the syringe with the air inside the barrel venting out. On the Edwards system, everything for the most part is very similar, other than the particular blunt cannula used has a little plastic shroud or collar to it, and this is used to place over the sampling port, and this collar is used to stabilize the syringe while drawing the blood sample.